Hi, I'm Kristen. In this presentation, I will discuss the study on neural flexibility and the propensity to change opinions following online media consumption. Our team's main research aim was to investigate the dynamic coactivity of neural correlates of opinion change as prompted by online persuasive news articles or social media posts. Our research team became interested in this topic because, as we witnessed today, persuasive media on Facebook, other social media platforms, or news sites has a profound effect on individual opinions and important decision-making. Information that you see and consume online has neurological and social implications, not only on the individual level, but also on the societal level. Digital media consumption may impact voting behavior, political partisanship, and even policymaking. Previous communication neuroscience research shows a significant relationship between frontal brain regional activity and opinion change. We further investigate this finding to explore the nuance in this dynamic neural activity within frontal brain regions using data that closely resembles a real-world scenario. Our main method, dynamic community detection, serves as our novel contribution to this literature. I will provide an overview of this method in a few minutes. We conducted an experiment in which EEG activity was collected from 240 healthy and diverse participants while interacting with biased content, such as inflated news articles or social media posts within a social media environment, which was actually created and programmed by our research team. Before and after interacting with the platform, we collected participant opinions via surveys on various sensitive issues, such as vaccinations, capital punishment or the death penalty, corporate investment practices, and politics. To determine behavioral change, we calculated individual opinion change scores before and after using the SMART platform based on their survey responses. Individuals who changed their opinion had a larger difference in their pre and post platform responses. To determine neurological changes, we estimated the statistical relationship of the EEG data between electrodes using WPLI, and we then input these matrices into the dynamic community detection algorithm to extract network metrics that quantify the probability of nodes, or electrodes in this case, to change their network affiliation across time. So the novel approach that we contribute to this communication neuroscience literature is a network science approach that determines a node's likelihood to join distinct communities over a certain time interval. These communities can be defined as groups or neighborhoods of nodes that are connected at some point within the whole defined interval. While many network metrics can be extracted, using this technique, we examine two key network metrics to describe the change in dynamic neural activity. We look at network flexibility, which is the average flexibility of all nodes, propensity to join different communities over time, and network promiscuity, which is the average promiscuity of all nodes or of nodes to join each community at least once over the whole interval. And we further use these metrics to explain a node's high or low flexibility within the larger network. These allow us to investigate the nuance in dynamic neural activity within the frontal brain region. From our analysis, we find that neural flexibility and network promiscuity of frontal nodes, specifically within the gamma and alpha band, during engagement with content online, are significantly associated with opinion change. The interesting and potentially surprising finding is that neural flexibility and promiscuity are significantly higher for participants who did not change their opinion. This means that network promiscuity and flexibility within these nodes in those participants who did not change their opinion join only a few network communities in the brain during opinion change. These results indicate that coactivity of frontal brain region or other network communities explains an individual's likelihood to alter their position on a sensitive issue. This work confirms prior work showing frontal nodes are significantly involved in this process. However, these findings are a little surprising because we would think that a neural flexibility would be associated with a more complex cognitive process like fluid intelligence or something like that. but we have to further investigate these findings, and our team is currently doing so. And so, yeah, a DT's work, I actually work with the DT who's also here and will be presenting shortly, but thank you.
Thank you very much for the talk. So we're still waiting for questions from the audience. Please don't be shy. Use the Q&A tool. Yeah, in the meantime, while we get some questions, I'm wondering, I'm very curious, what is the application of the, so how these results can be brought into the public, or I don't know, or eternally in the army? How is this used?
Yeah, so I mean, this is in terms of Army relevance. When we apply these findings in terms of we think about individual soldiers in teams working together, or potentially using some sort of information online, or like working with people who might be influenced by biased content. So the way that, by understanding how opinion change works, we can potentially mitigate malicious intent to change someone's opinion online. So our work basically just shows that it gives more detail into the neurological framework of opinion change. And I think there's probably many applications in psychology and other. But yeah, I think in general, it's more about potential interventions that could be developed to study terrorist organizations or extremist groups, and like how that content could trickle into certain communities online and affect various organizations and groups in the Army or in civilian circles.
Yeah, thanks for the answer. I think Sophia is asking if you can explain how all this may interact with fluid intelligence a little bit more in depth.
Yeah, so we are investigating that now, just because the finding was surprising. So fluid intelligence research shows that neuroflexibility and network flexibility and network promiscuity are higher in individuals who show higher fluid intelligence abilities. So comparing neuroflexibility to opinion change, which are both cognitive processes that incorporate metacognition, we would expect some sort of similar neural underpinnings in both of those processes. And so we anticipate that that potentially what's happening is that individuals who don't change their opinion may be spending more time thinking about, or more time analyzing content that disconfirms their original beliefs. So if you see something that if you see something that you agree with already, you're not really thinking about it that much. But you see something that you don't agree with, you have to like assess your own belief while processing that. So that involves some more complex process, such as similar to fluid intelligence.
Mm-hmm. Yeah, thanks.
Can I ask a question? Sorry.
Yeah, sure. Please go ahead. Yeah.
I because I'm nervous about my talk, I wasn't paying attention to the beginning. When did you measure the EEG? Was it while they were doing the task, or was that just like offline when they were just sitting, or was it resting state or something?
So it was while they were doing the task. Okay. So there's resting state, and then we have while they were using the platform, and while they were doing the surveys and using the platform. But we only looked at their survey, the differences in the EEG recordings of individuals while using the platform who changed their opinion versus not.
Okay. And do you think that it's a state or a trait-based thing? Like, do you think there are just people who are going to be one way, or do you think you can apply your measure to say this person is particularly in a mood to not change their opinion or something?
I definitely would say that it's probably, assuming that it's a trait is hard, because or I think just not reasonable. I would think that that this opinions and the responses that the neural responses and data that we collected would probably vary depending on certain underlying beliefs and conditions in that scenario. So we actually have more data actually that was not included in this study, but we also recorded EEG data of these same participants discussing the content that they saw together in a group. So from that, we can compare that data to see if somehow, because of those social interactions, their neural activity changed from when they were using the platform individually. So that's something that we're going to explore soon.
Cool. He's mute.
Thank you, Zip. I was typing. Yeah, no, I'm wondering if you know what are the proportions of people who are more prone to change their opinion than not.
Yeah, I don't know I don't remember the exact numbers off the top of my head, but there definitely are more individuals who didn't change their opinion
Okay.
than did from this experiment. But there's also some other members of our team are also investigating if the type of content. So the scenarios were corporate decision making, politics, your opinion on vaccinations, and the death penalty. So obviously, some of the information in those scenarios incites a different level of attention and emotion that depends on the individual. So someone might care a lot about vaccines while someone might be very anti-death penalty. So it definitely, I think it depends on the scenario as well. There's probably a lot of factors that we are investigating right now, actually. So
yeah, okay. Very interesting topic. Good luck with the future work, and thanks for presenting to us. I think we're going to move on now to the next speaker.